My name is Linus Stoltz. I'm the data manager for the Commercial Fisheries Research Foundation. We're based out of Rhode Island, Southern Rhode Island. I'm going to talk today. We've heard a lot of really great talks about lobster, obviously, that's why we're here, but particularly, thermal effects, temperature, data, how the oceanographic conditions are influencing lobsters and lobster dynamics. So I'm here to talk about an aggregated data product that was co-developed by CFRF and the Northeast Fisheries Science Center. So we've got our partners there listed. Do I have a clicker? Yes, I do. And but before I talk about FishBot, I'm going to talk a little bit about CFRF. We're a private nonprofit established entirely by the commercial fishing industry. We conduct cooperative research to fill data gaps, do outreach, education. Anything that's like broadly interesting to the commercial fishing industry is something that we actively pursue. We've got like tons of projects, 20, 30 active projects, all of different themes and flavors. So check us out. So FishBot is a fishing industry shared bottom oceanographic time series. You can tell we had some NOAA partners who were helping create this really sick acronym. So basically what this is a map showing the geographic extent of our data. So the need was, there's a lot of groups collecting in situ sensor data. Ourselves, we've got numbers of data sets, projects collecting ocean data. The EMOLT program, you probably may have heard about that. It's sensors on fishing gear. And then there's a number of other NOAA projects like the NOAA Study Fleet, the Ecomon survey, all of these different great data sources are all available. And so FishBot, recognizes that, okay, there's a lot of data out there, but it's all in different formats and locations, and you kind of have to know where to get it. So it's all spread out. So, we've taken, some of the data wrangling away from the end user, because, as a data user, you really want to be, getting into the analysis part. You don't want to spend your time wrangling all these different data sets and making sure it's all standardized. So this is a gridded product, 7-kilometer grid size resolution, and we bin all available data to create daily averages for temperature, salinity, dissolved oxygen. This is an extent showing bottom temperature. This is all bottom data. In addition to those parameters that I've shown, we have dissolved oxygen more coastally inshore. But in addition to those parameters, we have provide summary statistics as well. So you would get to find out like what the minimum was, maximum for these variables, the standard deviation, so you can look and see. Some of these have our long time series that are in a like let's say you've got sensors in a trap, so that sensor's sitting in one spot for the entire day, we also have like point casts from CTD measurements, so you can have a little more information and context about the type of data that's being collected. And then we tag everything with the data provider so you can really see a little bit more about that. And this all happens in real time, so daily at midnight it will update and reach out to the data sets. And I'll talk a little bit more about the things behind the scenes. But why did we create FishBot? I talked about these disparate data sources. There's I think 7 data sets being aggregated into FishBot right now. So, you have to know where those data sets are, how to get them, what to do with them. And people typically rely on modeled data for ecological research, and totally understandably so. It's very uniform. It's really nice to work with. It's one location that you can go to. But this is an example of, this is the ROMS model put together by John Wilkin and others out of Rutgers University. And you can see the dots on there are the inputs for these data assimilation models. So, generally speaking, this is very few inputs for ocean data being injected into this model to be able to generate those forecasts, be able to generate the hindcasts. And as we all know, this coastal region is incredibly dynamic, and most of our observations are actually on the continental shelf, right where fishing effort is taking place. This is super important to have in situ sensor data, and I'll talk a little bit about some model comparisons with this initial data that we have. But we've had a lot of stock assessment interest. So black sea bass, we've been approached, longfin squid. So Sarah Saloy is former NOAA. She was really instrumental in getting this just started for being able to look at indexes for long-fin squid. And of course, the reason we're all here, I guess I shouldn't assume the reason we're all here is American lobster, but I put it in the slide, so I'm going to say it anyway. So American lobster, it's, as we all know, it's thermally sensitive. So being able to incorporate in situ data to understand the ecosystem, as all these bottom-up processes we've been hearing about, is really valuable. So this is a little bit about the data flow for how the technical side of this works. If your eyes are glazing over, I can just breeze through this, but the source code is all on GitHub. It's documented. That's our link to our organization GitHub. And we can see we've got the data kind of flows from top to bottom. And so we have commercial fishing data. So that's the fishing industry shared part of this, which is kind of the initial push for FishBot. And so everybody who is partnering with the fishing community at scale typically makes their data accessible via ERDAP. So that's a great tool. I could talk for a really long time about ERDAP. So if you want to find me, buy me a drink at the bar and I'll talk about ERDAP. But everyone makes their data accessible on ERDAP. So once it's publicly accessible, FishBot is a program that reaches out to all these configured data sets and seeks to aggregate them on some scale. So like I said, it's real time. And we do this on kind of a dynamic refresh interval. So based on the calendar day, and starting daily, it will reach back and look and add and pull in the last 5 days worth of data from all the configured sources. And then biweekly, it'll grab the last 30 days from all the configured sources, and so on and so forth. Quarterly is a whole year. We can trigger a full refresh. Typically these groups that are doing industry collected data are very small. We try and make our data accessible in real time so that we have all employ kind of rolling QA/QC methods on top of our automated stuff. So I'll know that data makes it to our ERDAP, and I'll look at it and go, that's not good, so I'll take it off. But ERDAP is great, but it doesn't really tell other people that things have changed about it if they're using it. So that's why we do these dynamic refresh intervals to really aggregate everything. And I should say, I didn't mention this, but before we are aggregating new data into FishBot, we pull down what is already publicly available. We concatenate it into a single netcdf file, which we send to Zenodo through their API to receive a DOI, and that gets inserted back into the data set, which we then make publicly accessible on an S3 bucket, and then serve this as a companion data set. So if you are doing some analysis and you run your analysis on a Tuesday, no one wants to run it on a Friday and get different numbers because the data changed. So having this static archive that has a DOI that's incorporated into this, you can go and grab specific versions and share that data, cite that data, and it really provides a lot more reproducible science. So we've got 2 data sets for FishBot. The FishBot real-time, which has the cool features of a full-blown ERDAP data set, and then this archive, which is basically just a table with URLs. So you can just click on if you go to this data set, you can click on any of the links under the file URL, and it'll immediately trigger a download for the data set. And so this is another map. I'm just going to show the temporal spatial coverage. So the first map I showed was full-blown data set with everything. And this is by year, by provider, and I've colored, if you guys can see that, I've colored the regions of interest kind of underneath that, just to show that we have a very large geographic scope for this data set. So in situ sensor data is great. I'd love to see it being incorporated more. I think it's going to be a really nice tool for any type of ecological research that people would be interested in doing. And what I think is cool about this, if you look at the top, it ticks by through year. When you get to 2020, you see all of the Ecomon data go away because of COVID, right? But the fishing industry was out there, working hard, collecting data, and it's cool to see, kind of a companion, resilient, ocean observing, platform is always out there. So really, really neat. This next figure, once it goes. I bricked it. Oh, there we go. This next figure is kind of representing that previous map in like a little bit different way. So these are the data providers contributing to individual grid cells, so the counts, the monthly counts of them through time. So some really cool things you can see. The Ecomon survey, you know, they have a really large geographic scope for their survey, you know, Maine to, I think they go down to Florida, but we cut the range because we're interested north of Hatteras, but it's got a really seasonal, you know, cyclical seasonal pattern. When the survey goes out, you know, you see more observations. And then the study fleet program in pink there is a NOAA program. That picks up and carries a large chunk of the data set until we get to the EMOT program, which is just an absolute beast. It's really taken off, and you can see this huge amount of coverage. I almost couldn't believe this figure when I made it, because I made it in the spring, and we were like here. Now it's just like, it's blown up so much. So George Maynard is really great at being the EMOT coordinator, and it's really cool to see the scale of this. But I work for CFRF, and I just want to plug that there's a lot of data inside this data set. So it's a really cool tool. You know, we have the longest time series contained within FishBot for a given cell. So if you find, you can always find little treasures just based on the data, which I think is neat. And I want to talk at the end here about some initial model comparisons. So George Maynard made these comparisons of, this is against the GLORIES model, which is a reanalysis model product that is pretty commonly used in fisheries assessment. I know at the Northeast Science Center anyway. So observations, bars are, through time, you got month on the y-axis. So this is a direct comparison from the FishBot cell to the GLORIES cell, where data was available from 2007 to 2020. This is the mid-Atlantic bight, and we'll work our way north. And so anything above this red dashed line, FishBot, the in situ observations are actually warmer than the model predicts. So in the spring and early parts of the year, the water is actually warmer, like in some cases significantly warmer than the model is suggesting, which could really carry cascading effects down through your models and your higher order products that you're developing. So that's really an interesting phenomenon, and it really flips in August and September, and it's much cooler than the model is predicting. And going further north here in southern New England, or down in southern New England, I should say, in the summertime, June, July, August, September even, it's significantly warmer in the water than the model is suggesting. We're only as good as the data in our models, but this is, again, super preliminary, but it is a one-to-one comparison from GLORIES to FishBot, where data is available. And George's Bank here is also, it's warm. It's warmer than the model is predicting, which is, yeah, interesting. That's it. Model data is only as good as the models. We all know lobsters respond to thermal stress. And I want to close by saying that FishBot is modular, so if anyone in the audience has data, bottom data, if it's accessible, we would love to incorporate it into FishBot. So if you know somebody you like, somebody you don't like, anyone who's got data, I would really be keen to talk to them. This QR code is for CFRF. It's for all of our data products. It's our kind of data portal. So we've got other dashboards and data sets, and FishBot really unites all of our data. So all of our oceanographic data is united through FishBot, and in addition to aggregating other groups. So, and speaking of reproducible science, one last thing: all of the figures, I used a static archive, so you can cite it. It's cool. Yeah, thank you.
Great, thank you for this. This is really interesting to learn about. I just had a quick question near the end when you were talking about how the observations compare to the model results. You were talking about GLORIES, but you'd also mentioned John Wilkins' work, and I'm curious if you've also compared it to ROMS and Doppio.
We have not compared that. That's an excellent question. This is very preliminary. I'll go back to the models. This is very preliminary, just with the GLORIES. FishBot just started working this summer, and this whole mechanism. So this is a very new product. We would love to start comparing it to John Wilkins' Rob's model, also the Nikoff's FVCOM. That would be really neat to see as well. I'm also curious to see how well each model performs compared to the in situ anyway. So that would be really, really neat. But no, we have not yet.
Be better about checking online. Yep, okay. I've got a question. Yeah, I don't know how closely this relates, but when I see these maps, I'm always interested in the bathymetry, and I know that crowdsourced bathymetry is something at least the software providers like OLEX had pushed in the past. And I don't know is that something you guys have also compiled?
So in addition to yes, we
Okay.
have.
Okay.
So each grid cell, the coordinates that are served on ERDAP are the centroid of each cell. And so we take the centroid coordinates and assign the Gebco bathymetry profile, the nearest depth for that. And then we also have aggregated and labeled the statistical area that also applies to it. So we have the depth and stat area for each grid cell.